Hello everyone. Let's just wait for everyone to join in and then we can give it a start.
Hello.
Hi Rohi. Let me just start sharing my screen. We'll wait for 2 minutes and then we'll give it a start. I think let's give it a start. Let others join in as they find time. Um, just take this and share it on our group as well. If someone is trying to join, then they can directly join from that link, right? So I'll just paste it on. Just a moment. No, for me it is not opening. Not sure why Telegram is not opening, but okay. Fine. Let's actually give it a start then. Yeah. So yes, what we were doing is that we have looked until the correlation and findings and so on. So let's go ahead with the plan of action, right? Which we have already decided. Now, there's one thing I realized that I have missed while doing the scaling of the feature. So let me just put it over here because this is really important. Call this point number 5. I'll change this to point number 6. So point number 5 is if you have any categorical variables. Okay, this is not the case with us. Okay, we don't have any categorical variables as far as I know, which is in a non-numeric format. Okay, so for example, we do have one categorical variable. I believe that variable is CHAS, right? CHAS is the variable which is one if the housing or the dwelling is near to that, let's say, a river, right? But if it's not close to the river, then the value is equal to 0. So that's the meaning of that variable. So we also saw there was an imbalance in the data. If we remember, the values of 0 was higher, the values of 1 was less, right? So if we have any categorical variables, right, in our data, and that categorical variable which we have in our data is in textual format, right? So let's say the categorical variable is like the furnishing status of the house, whether that house is furnished or unfurnished or let's say semi-furnished. So if you have that kind of uh, a situation, right? So it is actually better to map them, okay, to encode them, okay, and we know how we can encode them, right? We know how we can encode them. We can clearly encode them in two different ways. We have a technique which is known as one hot encoding. We have a technique which is known as uh, hi Isha. We have a technique which is known as dummy variable encoding. We have a technique which is known as one hot encoding. So we know what to do. Okay, but I would strongly recommend that we should, okay, we should try and not do or we can actually use any of the techniques over here, because both of the techniques is doing what, it's limiting your range of data within the values of 0 to 1. So almost overall it's not going to make a much of a difference, okay, when it comes to regression. When it comes to classification, there will be some other things that we have to take care of. But clearly, if we have categorical variables, if we have any categorical variables which contains textual data, then we need to how can I say, we need to encode it, okay, encode it too, okay, using the methods which we are already aware, which I'm not really writing over here because we know what methods we are going to use. So let's follow the plan of action. But I did a quick mistake. I see again. I see I have done a mistake. So maybe what we can do is that we can do this before we scale the features, right? So we can do it like this. So I'll take this and I will put it over here, and this can be removed from here, right? Or even better, I will do this thing, okay, over here, right? And now what I'm going to do, just to avoid this problem of numbering, I'm just going to remove the numbers. I'm going to put hyphens over there, right? So I believe this is going to be a good plan of action, because if I divide the data even before doing VIF or RFE and all these things, and that's really not good. Okay, so let's try to do it in a very proper and sequential way, and then we'll see how it goes, right? And then we'll see what we can do to improve the model. Okay, so let's start with doing VIF. Okay, so to do VIF, let's import the module first. Hope to some extent we remember it, but it's not really required that we remember everything. It's really not required. We have everything in the documentation. We don't need to remember this. So I'm just going to import the library which I'm going to use to do VIF. So that's part of the stats models package. So from stats models dot stats dot outliers underscore influence, okay, influence, I'll import variance in inflation factor. Okay, so I will import this specific, let's say, module, and then what I'm going to do is that I'm going to create a data frame called VIF. I'm going to store all my VIF related information into that, let's say, the data frame. So I'm just importing two cells over here so that I can beautify it, nothing related to code. So performing VIF. Okay, so now what I'm going to do, I'm going to create a new data frame VIF, which is PD dot data frame, and it's an empty data frame, right? I'm not writing anything in there. I'm going to fill the details, so don't worry, right? So what I'm going to do now is that I'm going to do VIF. I want to add a column. Okay, I'm going to add a column in this data frame called features. Okay, and this is going to be, I have my list which contains the feature columns, right? That I can use, or I can simply use features dot columns. Okay, I can simply say features dot columns and I will get the column names. Right, so I have two ways of doing it. I already have a list of all the columns which are there in my features, right, which I believe should be here. Yeah, features, right, features dot column, right? Okay, auto generate, right? So if I look at VIF features, I'll get the same column names. Okay, so these are the column names. The column names of my data I have inserted in each and every row. Okay, in each and every row of my VIF, let's say, data frame. If I just do this, I'll be able to see it properly like a data frame. Now the next column I'm going to add is going to contain the VIF. So I'm going to say in the data frame VIF, add a new column called VIF, which has to calculate my variance inflation factor. So how am I going to do that? Is that I would like to write an inline function. So I'm going to say variance inflation factor. I want to calculate this. Okay. I want to calculate this variance inflation factor using the uh, uh, the values, okay, or the actual values in the rows which is there. Either I can do this using my training data, okay, or I can do this using my actual data. So I have my actual data, which is my Boston data set, and in here I can call a method known as values, right? If you would like to see what this values thing does, you can simply say Boston.values, and you will be able to see that it is actually printing you all the values. Okay, it is simply printing all the values in there. Okay, is this really the right set of values? Yes, Boston, yes. Let me just see. Boston dot head. Yeah, yes. Right. So these are the values. So Boston dot values. If I do a values, I'm going to get what? Only this much part. I hope you got the idea. So I'll get only the values in the data frame in form of an array. So I just want to create an array which is going to contain the values, which I have to pass over here. Okay, I have to pass it over here, and I have to pass some iterator as well over here. So that's my objective. I'll show you how to code this now. So I'm just going to say Boston.values, comma, I. Now, what is this I? For I in range of, okay, range of something. And that something, okay, is going to be my Boston.shape in the brackets 1. Now, let's see what is Boston.shape in the brackets 1. Okay, if I do this, this is the number of columns. Right now, if I look at this, the number of columns is what? The number of features as well as the target. This is not what I want. I want the variance inflation factor, okay, considering only the features. So if that's the case, because variance inflation factor is what? It is the quantitative idea about how much the feature variables are correlated with each other. That's it. Right, VIF is otherwise given as, if you remember, 1 divided by 1 minus r square. It finds the r square value of a feature I, and it simply does 1 by 1 minus r square, which gives you the variance inflation factor of that variable or that feature I. And this number gives you a basic quantitative idea, numeric idea, but how much the feature variables are correlated with each other, right? With respect to the feature I. So how much is that feature? In other words, how much is that feature, that column I, is affecting the rest of the features, right? So if I'm only going to be concerned about features, let me only take the features, right? So I'll just replace this with features. Hopefully, features dot shape 1 should be 13, right? Because I have only 13 features. So let me delete this line and let me execute this line, right? So I've got the VIF. Right now, what I am going to do is that this VIF is usually a fraction. Okay, I don't want a very big fraction. So what I'm going to do, I'm just going to change this uh, columns structure. Okay, like this. Okay, so I'm just going to say round the values to 2 places of decimal. Right, and I'm going to say enter. Okay, now I have got the data. Now I would like to sort the data as well, basis the VIF values. Okay, why I'm doing this is so that I can understand which values are having, or which features are having VIF which is more than 5. If I have features where VIF is more than 5, okay, definitely you should get rid of them. Okay, definitely they should not be included in the model. Okay, you should not use those where you have such kind of cases, right? So, and then we can drop these variables, and we can drop these variables from our features, and then we can continue creating the model. So that's one way, right? So let me just sort this frame. So what I'm going to say, VIF, I would like to sort the data frame itself. So I call the data frame is equal to VIF dot sort. Okay, and in the parameters, or even better, I'm going to say sort values, and in the parameter I'm going to say by, sort the data frame by the column, by the values in the column VIF, and I do ascending is equal to false, right? So what this is going to do, in the descending order, by the values in the column VIF, sort my data frame VIF. Now I do a print. Okay, now you see what is happening over here. I have a lot of variables which is very high, really very high VIF, real high. Okay, this is very bad. Okay, this is really very bad. We can get rid of a few. Now my problem is, what if I try to get rid of them and then I cause loss of information? Because I can, yes, I can get rid of, let's say, PT ratio and try to see what happens to VIF again by executing the code. Now, what if, okay, what if PT ratio is really a very important factor? Because as far as I understood the data, PT ratio is really important. You see, NOx, RM, PT ratio, LSTAT, these are features which have at least somewhat linear relationship and very good correlation, right? So this is part was bad, so, at least somewhat good, at least somewhat good correlation as per heat map with the target, right? And this will be, don't have good correlation as per heat map, okay, with the target, right? So I can clearly see NOx, RM, PT ratio, LSTAT. These I cannot remove, right? I may be able to remove ET ratio, but that is going to cause a lot of loss in my data itself, in the quality of the data. So let me just put this value over here so that I can refer to it over here. So I'm not going to remove these. Let me just zoom out a little bit, right? So I have this output of variance inflation factor, and here I can see PT ratio is quite high, but I cannot remove that. Can I remove RM? No. Can I remove NOx? No. Can I remove tax? Yes. Yes, I can remove tax because tax has not a good correlation, right? Tax has not a good correlation, right? So what I can do, I can simply say features dot drop, right? Features dot drop, and I'm going to drop the column tax, right? Axis is equal to 1, in place is equal to true, or if I do an in place equal to true, it replaces, okay, it replaces the data entirely. So in the original data frame itself, it's going to replace it, right? So should I be doing that? I can do that because I have another data frame, right, which contains all the features and the targets. So I can do that. Or if you want, you can create a new data frame as well. Depends. So that's up to you. A thing that you need to be really worried about. You can create a new data frame. I could have actually written features 1 is equal to features dot drop this and this and this. In that case, I don't need to write in place equal to true. Okay. I hope you got the point, right? Now, what we are doing over here is, now that I have dropped it, okay, now that I have dropped it, okay, let me again calculate, okay, let me again calculate the VIF. Okay, so what I'm going to do this time, okay, this time I'm going to take the code at once. So let me just do this and let me copy paste these things. So I'm going to copy this come over here. Feature columns is this. Then I'm going to do this. Okay, where I'm calculating the VIF. Okay, then I'm going to do this, and I put it over here, and then I'm going to do this, right? And then I'm going to print. Now, obviously, you can clearly see, okay, you can clearly see that this is going to be reused from time to time. So why not convert this into a function? Okay, why not convert this into a function? Let's try to write a function for this. So def calculate VIF. Okay, in the input, I'm going to pass the data frame. Right, I'm going to pass the data frame. I need the features data, right? Or else I'm going to simply write features. So I pass features and it's going to create a new data frame called VIF. It's going to have the new columns. Okay, it's going to have this, it's going to have this, it's going to have this, and then it is going to return me the data frame. Right, let's see if this works. Calc VIF, and I'm going to pass features. Okay, see, it has worked. It has actually given me all the variables. Right, do you see any difference in this VIF as opposed to the last VIF? See what is happening here. We try to see what is happening. PT ratio was 85. PT ratio had a value of 85. Now it has come down to 82. Why? Because I have dropped the tax column. As you go on and drop all the unnecessary columns, right? As you go on, as you drop the unnecessary columns, the variance inflation factor or the rest of the variables also come down, right? Why do they come down? Please try to remember what is variance inflation factor. 1 minus 1, 1 by 1 minus r square. So by reducing the effect of one variable on another, you are actually increasing. You are actually you are actually decreasing the value of r square. So this value, this VIF value is going to decrease, right? This overall value is going to decrease because you are changing the value of r square. If you are changing the value of r square, to make this value decrease, what? You need a very big denominator or a small one. You need a small one or a big one. If I want to make this function, the output of this function, a very small value, right? If I divide 1 by 1, I get 1. So I cannot have this one. I need smaller than 1. Right? If I need smaller than 1, I have to make this value high. Right? If I have to make this value high, I have to make this value small. Right? So this is exactly what I'm trying to do. And by removing the features, which is non-important, right? In that way, I'm just trying to ensure that my VIF comes under control. Did every one of you understand this? Any doubts from anybody? Saransh, Rohi?
No, Bhumik, I got it. Understood.
Is there any doubts from your side? No, I think she's on mute. Okay, I will assume that you have no doubts. Give me 1 minute. Okay, now the second, what we can really remove now. So where was my list of features? Here, right? Yeah. So NOx RM PT ratio LSTAT. This I cannot really remove. PT ratio RM NOx LSTAT is here. So I can remove age. Age I can remove, right? Age I can remove. So let me just take this. right? And I will put it over here, and I'm going to say drop age. Okay, in place is equal to true. So if I drop this, now let me again calculate the VIF using features. Okay, is the VIF really decreasing a little bit? It has decreased. Okay, 82.36, 82.23, little bit. Okay, then what is the next column that I can drop? I can drop B. Okay, I can drop B. So let me just skip ahead to one place maybe. So although you should not be doing this, but I'm just trying to make my life easier by by passing it a list of lists, and I'm going to pass more than one column. I'm going to pass B. DIS is not part of my important column, so I can drop. Okay. Then I can I drop Indus? Indus is there? No. In Indus I can drop. Indus I can drop. INDUS I can drop. What is the next field that I can drop? Uh, then I have LSTAT I cannot drop. RAD I can drop. Okay, let's drop three of them. Okay, and then we are going to see. Let's see if this is really going to work. Not sure if this is going to work. No, this wouldn't work. I just need to pass a list like this only. Let's see if this one works. Yeah, this works. And then I'm going to say calc VIF features. Okay, if I do a calculation, now you see how much the value has actually decreased. Right, it was 80 something, now it has decreased over to 66. Right, what is the next feature that I can drop? RAD CRIM. RAD CRIM I can drop. What is the list of important features? Let me just copy this over here and put it over here. Sorry, not sure why it is not allowing me to copy paste properly. That's a very important function, right? So RM I cannot remove, PT ratio I cannot remove, NOx I cannot remove, LSTAT I cannot remove. So the rest I can remove, right? So features dot drop. Okay, I can remove RAD, I can remove CRIM, and I can say axis is equal to 1, in place is equal to true. Okay, now I do again a calc VIF features, and then I get this. See, it has dropped, but it has dropped some amount. I mean, it's not really that big, but it's really some amount. Now, as you can see, what is happening over here is, if I again come down over here and I say ZN and I say CHAS, okay, and I drop them, okay, and then I do a calc VIF on features. Okay, I still have features where the VIF value is greater than 5, but okay, but I don't have the audacity to really remove them. Why? Because I've already found out that these four columns, okay, these four columns are really having good correlation. I'm not saying causation, but they have good correlation, right? So this is one finding. It did not help much. In our case, it did not help much. We can go ahead by creating a model with this, right? Later on, when we do unsupervised learning, we are going to look at things like PCA and so on. But as of now, can we really create a model with this? The answer is okay. Yes, we can try to create one model, right? We can try to create one model. That's not really a bad thing to do, right? But then the indication that I have PT ratio of something like this is not really good with respect to my data. Maybe after I scale my data is going to become good. Okay, maybe after I have scaled my data might become really better, right? So as of now, I cannot do much other than this, because I have to stop doing VIF over here, right? I cannot really do more VIF here. Okay, I really cannot do, because I cannot drop the rest once, right? It is really important for me, right? So now what I can do, I can use another technique, which is RFE, right? I can use another technique which is known as RFE. right? Now, how do you use RFE? RFE is known as recursive feature elimination. Now, we are going to look into that. So let's say, let's now perform RFE. VIF did not help us much since at the end, we still have very high, okay, very high VIF, very high VIF in the leftover features, but we cannot drop them as they are quite highly correlated, okay, quite highly correlated with the target variable. Okay, there are other ways of identifying the variables as well, where which you can drop from VIF, okay, or during the VIF part. I'll just quickly tell you, maybe we'll not do it here. So one more way of identifying the features that you can drop, right, from your VIF is by doing a stats model linear regression. So you fit the model, you don't do anything, you don't remove any variables, simply import the library, fit the model. Fit the model using stats models. Don't do it using sklearn. Why? Because stats model is an open source and an open box library, which means it is going to show you the p-values. The p-values will be shown for each and every feature. Now you already know what is the significance of p-value. The higher the p-value, the higher the p-value, the bad it is. Right? The lower the p-value, it is good for me. Why? Because then I can reject my null hypothesis. If I have a higher p-value, it means I have no option to, or I have no proof to reject the null hypothesis. The lower the p-value is, it means my finding, my alternate hypothesis is not basis random chance, right? Higher the p-value means there's a very high probability that whatever my alternate hypothesis is purely by chance. So I can use that kind of a technique as well. You can fit the model using stats models, right? Using by the same way which we have done earlier, right? You can look at the notebook which is there in the statistics section, right? Where we have added a constant. I hope you all will be able to recollect how we did that. So we added a constant, right? Which was a constant value which is not added by, uh, or which is not added, right? In case of a simple linear regression, we added it, right? In case of multiple linear regression, we don't need to add that mandatorily. It is good to have be added. Now, we did that, and then what did we do? We simply fit the model, and it gave us a very long output, right? It gave us a very big table from where we are able to find out the p-value and so on and so forth. And then we were also able to identify which all are the features which are really contributing to the model or which are not contributing to the model. So looking at the p-value, we are able to see if our model was good or not and so on. So using p-value also, okay, using p-value also you can do this, right? But please also keep in mind, just by looking at a p-value, you should not be taking a decision. Then you are doing the same mistake which a statistician will do. As I said in many of with these occasions, we are, when we are doing such kind of an analysis, when we are doing such kind of an implementation, we are not supposed to look at a problem statement only from the statistician's point of view, because then I'll only go by numbers, right? My human factor goes away. So you have to keep that in mind as well, because these four variables, for example, have a very good relationship with the price of the house. We have already written that in our text, right? We have already written that in our text. PT ratio is what? If you look at this, PT ratio is people teacher ratio by town. Obviously, it has a very good impact on the price of the house, right? It has a very good impact on the price of the house. RM is average number of rooms per dwelling. The more the number of rooms, obviously, the higher the price will be. If you have a 2 BHK and if I have a 4 BHK, obviously my 4 BHK is going to cost more than your 2 BHK, right? It's just a no man's thing to understand. It's a very, very simple thing to understand. So these are variables that I cannot get rid of. I cannot go to my business and say get rid of these features because I have a very high VIF. Okay, at that point in time, I have to keep a balance. Okay, I have to keep a balance between the the numeric side as well as the statistical side, or the numeric side as well as the business side, right? So, j- us to recap, using stats models, we can create a linear regression model. From the model's output report, we can find out those features uh, which we already know to be non-important, and we can try to see what their p-values are. If the p-values are very high, let's say going closer and closer towards 1, the ones they are there, try to remove them, your job is done, right? But still, in that case, I don't know whether that would have helped here or not, so let's not uh, get into details of that. But we can use RFE. So to do RFE, what I'm going to do, from sklearn, now I'm changing the library, from sklearn dot feature underscore selection, import, okay, import RFE, right? And that is this RFE function, okay, this RFE function is going to help us do the ranking, right? So what do we really do in this case is that we have to create a model, and then only, okay, and then only we can try to understand uh, how recursive feature elimination helps us to find the good columns. So for this purpose, this being the limitation, so what I have to do, I have to import the linear regression module, and I have to fit a model just for a temporary purpose. Okay, so we are not going to take this model very seriously. We're not going to look at the coefficients and so on. We're just going to fit the model and pass the model to my friend RFE, and our friend RFE is going to tell us, okay, this is what it is. Okay, from sklearn dot linear model import linear regression. Okay, I've not even divided the data into training and testing set, because I'm just trying to understand the features. It is really not required for me to divide data into training and testing, because I'm not going to validate this model that I'm going to create over here. So let's say I'm creating a new model LM, okay, or I'm going to call it LM test is equal to linear regression. So I'm not going to test the validity of this model, right? So it doesn't matter whether I have a training set or a testing set. Now what I'm going to do, LM underscore test dot fit. I'm going to fit my data. Okay. Now there is a problem. The problem is I need the features and the targets. But in the features data frame, right, I have already dropped the columns. Now how do I get them back? Okay, let's first get them back, and then we are going to do this, right? So let's first get them back. Okay, how am I going to get them back? I can do this, boston.columns. I have the data frame here. So what I'm going to do, features is equal to Boston feature columns. Do I have a variable called feature columns? I believe I do, right? I have a list which contains all the feature columns. I'm just going to pass this column. I'm going to cut this. I'm going to delete this, and I'm going to paste it over here. So I'm just going to say, create me a new data frame, which is going to have my features one more. So now I have all the features. I'm redoing the exercise which was concluded in VIA, but I am trying to redo it, right? So I'm going to fit the features and the targets, right? So my model is fit, right? Now what I'm going to do, I'm going to create an object of RFE from this class, and I'm going to pass my model LM underscore test model, and I'm going to say how many features do I have. Here I have 13 features, right? I have total 14 columns in Austin data. You see 1, 2, 3, 5, 7, 9, 10, 11, 12, 13, 14. This 14th column is my target. So the rest 13 are my features. So I have 13 features. I'm going to pass the value over here 13. So I want to consider all the 13 variables. I don't want to do any top 5 or top 10 kind of a thing. The number which you pass over here, the second, it's the parameter, right, is going to help you control how many features you would like to concentrate yourself on. Let's say you want to create a not a very robust kind of a model, but very easily actionable model, in which case let's only focus on the top 3 factors, right? If a business focuses on top 3 factors other than 13 factors, To invest money and to plan for how to control and how to regulate 13 factors is really difficult. Rather than if you concentrate only on 3, it will make your life quite easy. But I'll start with 13 and then I'll see what I can do. So I'll take all the variables at the first place, right? Now I can ignore no, not the warning. It's really not going to do anything. So now what I'm going to do, I'm going to do a fit on RFE, and I'm going to take my features and targets. If I do a fit, okay, after it has fit the outcome, it has stored its output inside this variable. I want to get that output out of it. Okay. See, it has n features to select equal to 13. It has done. So features to look for, a number of features to select from is equal to 13. Right now, what I'm going to do, I need a list of, okay, I need a list of uh, features dot columns. Okay, I need a list of features dot columns, and I need RFE dot support. Right, support is whether RFE supports this certain feature to be there or not, and another parameter is RFE dot ranking. Okay, so I need in my output 3 fields. Okay, I need the column name, I need the information whether RFE supports the presence of that column in my model or not, and then I need the ranking, which one has the top ranking, which was has a second ranking, and so on. Okay, so I need these 3 things. How do I get them? I'm going to use a specific Python function, which is my zip function. Okay, and then I'm going to convert this again into a list. So if I do this, I get the output. You see the problem over here. There is not even a single variable which it is saying that it doesn't have to select. Why? Because number you have given is 13. Right? What if I change the number? So let me just change the 2, and I'm going to just pass LM test, and I'm going to say top 5. Okay. Now I'm going to say top 5. So I'm going to say RFE.fit, and I'm going to pass the features and the targets. Okay, now it is taking n features to select equal to 5. Let me just quickly copy and paste this so that I can save some time, and I get the top 5 feature. Now, what it does with respect to top 5 features is it is specifically selecting, it is giving you a value of 1. Wherever you're seeing a value of 1, okay, whenever you're seeing a value of 1, these are the features which it is saying is of most importance, right? Which is of most importance. So clearly see which features it has selected. It has selected CHS. Let me just write it over here. CHS it has selected. Okay, CHS it has selected. Okay, so the other way of doing is, if I'm not wrong, okay, the other way of doing it, maybe what I can do is that I can say features dot columns, and I'm going to say RFE underscore support, RFE dot support underscore. Yeah, see, CHAS, NOx, RM, DIS, ET ratio. These are the 5 columns it has selected. Is this matching with our finding or not? Let's go back to our text pad. We said NOx, RM, PT ratio, LSTAT. Just take this part and I'll come over here, put it inside this. NOx is there, RM is there, PT ratio is there, LSTAT is not there. In place of LSTAT, it has selected CHAS and DIS. LSTAT, it is saying it is not really in the top. In the top 3, it is not, it is false, right? Because I selected the top 5, right? If I change this, let's say, if I now change this to, let's say, top 6, maybe it will come into picture. Or maybe if I do top 7, right? And then if I feed the model, I'm going to see that it's going to take LSTAT as well. So I have now top 7, which contributes more statistically to the model. right? I can take this. I can take this and I can go ahead. I can take this and I can go ahead. Clearly I can take this and I can go ahead. If I want to know which columns are not supported in this model, in this out of the box model, all I need to do is that I can do this. Okay, these are the columns which are not supported because I have taken 7 columns. So let me just reduce this to 5. I just want to create a very simple model. I don't want to complicate my model. I just want to create a very simple model. That's why I'm now taking only the top 5. Okay, so the top 5 columns which contribute most to the model are these, right? Now, what do we have as part of our plan of action? I hope you have understood what we did in VIF and RFE, right? So what is there in my next plan of action? Do the feature selection. Okay, let me copy this. Okay, let me copy this into this plan of action, POA. Plan of action is this. So perform VIF and RFE to understand which feature. This is done. So I'm going to mark this as done. Do feature selection based on this findings done. I'm going to select the one that has come out of RFE. Okay, and that's just my choice. You can go ahead with the VIF one as well. Okay, whichever relates to your business. Try to combine the statistical output or the mathematical output with the business needs. Don't ignore the business side of things. Okay, we cannot simply go with the numbers. Right now, the third thing is divide the data into training and testing. This is what we are going to do. Okay, so let's go ahead. Hope until this point there was no questions, right? If there are any questions, friends, please go ahead.
Bhaumik, I don't have any specific questions. Just one thing. So this VIF thing, right?
Yeah.
Uh, I don't know. Somewhere I heard that if it is above 10, it should be taken out. The feature having VIF
Mhm.
above 10 should be taken out.
Yeah,
But
that is also a parameter. Yes.
yeah, but I mean the VIF which you have done. I mean the logic is same, but the way of seeing is different. I mean, how are you getting higher values?
So see how I am getting the higher values over here, right? That's a problem with the data. So if I am getting these kind of values which are really so high, right? This is actually an issue with the data. Maybe this data is a cooked up data. Maybe this data is really having a lot of, let's say, distributional errors. Because if you have seen the kind of analysis we did yesterday, we saw a lot of areas where we have distributions looking like this. Or this usually also happens with bimodal data as well. So there are issues with the data that I can understand. Yes, but what you are saying is yes. What you are saying is also correct. There are many cases that is also a very standard practice that we also usually follow things like 10 to 15. We can select our own, let's say, benchmark of let's say 10 to 15, and we select the top features. Right? That's also done into VIF.
Yep. Okay, Bhaumik, that's all. I
Yeah.
mean, other things are clear.
Okay. Okay, so what I have done quickly when Saransh was asking the question is that I have created a new data frame called Boston Final. Why? Because I need to be very selective now on these columns, right? I think I have done a big mistake. I had to select this and I selected the wrong list. Sorry, friends. Let me just correct this. So I have now created a new data frame called Boston Final, which contains only that much data that I'm going to use to uh, create the model. Okay. So I'm going to use Boston Final, right? So let's just try to fit my model and let's see, okay, how it is going. Okay. So let's try to fit my model. But before fitting my model, I need to get the train and test splits, right? and then I can fit the model. Okay, so let's do a splitting first. So to do a splitting, what I'm going to do from sklearn pre-processing import train test split. Sklearn, oh sorry, they've changed it, model selection. Right, now what I'm going to do, x train x test y train y test is equal to train test split x comma y. Okay, and I'm going to say random state is equal to 101, and I'm going to say I'm not going to say anything. I just want that 70-30 division. I'll not use that other variable to define the train size or the test size because it doesn't matter. So let's take the default values. I mean 70-30 is good, it's not bad. Okay, let's go ahead with the default value. We'll see if the model is not good, we'll improve, right? So let's create the training and the testing sets. So let's see what it has done. If I do extend shape, it has 379 rows and the 13 columns, and x test dot shape should be just the opposite. So 379 plus 127 should be 506, right? So that's how it is. Now I have to fit my model. So I'm going to create a new model LM1. Okay, that's how I can number them 1, 2, 3, 4, 5. So model number 1, linear model 1, is an object of linear regression, right? And I'm going to say lm underscore 1 dot fit. Okay, x train y train, right? It's the same way which we did earlier as well. When we did the linear regression earlier as well, this is what we have done. We have taken the training data and we have fit the model. Now we want to get the prediction and we want to calculate the R square and all these things, right? So to get the predictions, we have to use the X test data, right? We have to use the X test data. We can use the X test data, and from there, right? From there, we can get the ypred, let's say. So we are going to call this variable called ypred. Okay, ypred is equal to my model lm underscore 1 dot predict, right? And I'm going to say x test. I'm going to pass the variable as x test. Now I have ypred and I have y test. Okay, so if I do a zip of ypred and y test, I should be able to see what it is doing. So ypred, this is my predicted value, this is my actual value, this is my predicted value, this is my actual value. There are some cases where it is really differing a lot. For some cases it is really close. You see, these are the cases where it is close. It predicted 31.4, actual value is 30.8, although not exactly close but quite close. But then there are cases where it is really very big. The prediction is 40, actual is 50, right? So this is something that we have to see how it is going, right? But is there any linear kind of a relationship between ypred and y test? Let's see. So what we can do to do this is that I can say plt dot scatter. Okay, and I'm going to pass the variables y test and y pred, right? So I just want to create a scatter plot of the test values and the prediction values. I just want to see what is the shape, right? Or the comparative shape. Give me 1 minute. Okay, so let's do a scatter plot, and I'm going to say plt dot show. So if I do a show of this plot, let's see how it looks like. Is that really a linear kind of a line? It's quite a linear line. It's not a very good model. If my model would have been very good, right, if my model would have been very good, then I would have got all the points in this line. All the points should have been in this line, because why am I trying to draw this line? This line drawing is actually wrong. Let me take a pen and show you. The concentration, right? The concentration of y test and y pred. So this is my test value. These are my test values, and these are my predicted values. If I have done very good kind of prediction, right, the points of test values should exactly overlap with the predicted values. And if that happens, okay, if that happens, then the concentration will not be so much spread out. Okay, it should be something like this. If I only draw the spread should have been this. This would have been a beautiful model. Or maybe a very acceptable kind of a model will be something like this, right? But what I have, the shape that I have, is kind of scattered. There is some part that I can try to generalize. This part is good, right? Maybe I'll even include this much part, right? But other than that, I cannot do anything. These points are really wrongly classified. There are a lot of points which are wrongly estimated, right? So my model is not really very good. Okay, there are reasons why my model is not really very good. We have not used those things over here. That's why our initial model, the one that we have created over here, is really not very good. But we are out of time, so let's write what we are going to do next. We got a initial but not so good model. So how do we improve? Okay, the points will be, we can scale the features. Okay, we have not done this. We can scale the features to improve their range and to improve their mathematical essence, right? So that's the first point. The second, what we can do uh, is that maybe linear model is not a good fit here. We can try non-linear models. Okay, explicitly for each model, we should check how much RMSE, root mean squared error, and R square, or even better, adjusted R square values are, right? So we are going to do this in the next session. We will do this on Monday, right? So we will have our next session on uh, Monday at same time. And at that time, we are going to do this kind of plan of action, and we are going to continue with the rest of the plan of action as well. So training and testing we have done. This part is done, right? This part is done, but we have not done scaling. Okay, this part is not required. So I'm going to say there are no categorical variables which are represented as text, so I do not need this, right? And then I will find the coefficients or the equation as well, right? So this plan of action, these findings is there, and then we have a rough plan of action over here. I would then stop the sharing, friends. Let's meet on Monday, and then we are going to continue. Thank you so much.
Yes.
Have a
Thanks,
good
Bhumik.
weekend.
Thank you.